Elon Musk has just released a controversial analysis claiming interstellar object 3I, ATLAS, violates the laws of physics. The SpaceX CEO's calculations point to an energy gap so massive it challenges our understanding of celestial mechanics. The evidence is real. The data is confirmed. The implications are staggering. Here's what triggered this bombshell. On November 10th, Musk published numbers showing the object is losing matter at an impossible rate, 2 million kilograms per second. That's enough mass to drain a small lake every single second. Picture a mountain of dust and gas exploding into space every second without stopping. The problem isn't the mass loss itself. It's the energy required to power it. Musk's calculation is brutally simple. Take the sunlight hitting the object. Calculate the maximum energy that sunlight can provide. Compare it to the energy needed to blast 2 million kilograms of matter into space every second. The numbers don't match, not even close. The sunlight comes up short by a factor of 10. Think about what that means. This object is acting like it has a hidden power source, an engine we can't see, energy from somewhere else, and that's just the beginning. The supporting evidence makes this even more controversial. On November 6th, astronomers at the ATLAS Telescope in Chile recorded something unprecedented. The object brightened by 40% in just 48 hours. Not gradually, not smoothly, like someone flipped a switch and turned on stadium lights. That's not how comets work. Normal comets brighten slowly as they approach the sunday. They warm up gradually. Ice turns to gas predictably. This object, it lit up like it was responding to a command. But here's where Musk's analysis gets really interesting. The Lowell Discovery Telescope captured something else on November 7th. The object shifted sideways, 15 kilometers in 3 days. That might not sound like much, but for an object moving at interstellar speeds, that's a massive deflection. Something pushed it hard. The force required to create that shift doesn't match any natural outgassing pattern we've seen before. Let that sink in. We're not talking about measurement error. We're not talking about orbital mechanics. We're talking about a force strong enough to shove this object across the width of a small town in 3 days. Musk's numbers get more troubling when you examine the gas output. The object is ejecting 500,000 kilograms of material every single second. That's not a calculation. That's a direct observation from spectroscopic analysis. The Clerk Maxwell Telescope confirmed it on November 5th. 500,000 kilograms every second. Here's the problem. Early size estimates suggested this object was maybe a few hundred meters across, maybe a kilometer at most. An object that size shouldn't have enough material to sustain this kind of mass loss. Do the math. At 500,000 kilograms per second, a kilometer-wide object would be completely vaporized in weeks. Yet it keeps going and going. The energy budget makes no sense. Musk frames this as a fundamental physics problem. Either our size estimates are completely wrong, or the object has an internal energy source, or the laws of thermodynamics need revision. Those are the only 3 options. Pick one. Most scientists won't touch option 3. That leaves 2 possibilities. Either this object is much larger than we thought, or it's generating energy internally. But that's where the official story starts to fall apart. The Minor Planet Center released updated orbit calculations on November 8th. Their models show the object following a hyperbolic trajectory, standard interstellar path, nothing unusual. Except their models can't explain the brightness surge. They can't explain the sideways shift. They can't explain the massive gas output. The models just ignore it, Doctor. Catherine Ramirez from the ATLAS team offered an explanation on November 11th. She suggested sudden outbursts can mimic high energy output without breaking physics. Ice pockets deep inside the object could suddenly vaporize, create a jet, push the object sideways, brighten the coma. Sounds reasonable. Until you run the numbers. For an ice pocket to create this much energy, it would need to be massive. We're talking about a frozen lake buried inside the object. And it would need to vaporize instantly, not over days, not over hours, instantly. The thermodynamics don't work. Ice doesn't behave that way, not at these distances from the sundae. Professor Aisha Lahari from the University of Arizona proposed a different mechanism on November 9th. Dust jets, asymmetric outgassing, rotational forces combining to create the observed effects. Her model explains the sideways shift. It explains some of the brightness change. It doesn't explain the energy deficit. That's the core issue Musk keeps returning to. Where is the energy coming from? Sunlight at this distance provides a specific amount of power per square meter. You can calculate it precisely. No ambiguity, no uncertainty, just physics. The object is using 10 times more energy than the sun provides. 10 times. That's not a rounding error. The mainstream scientific community is struggling with this. Most astronomers default to measurement uncertainty. Maybe the size estimates are wrong. Maybe the gas output is overestimated. Maybe the brightness measurements have systematic errors. Maybe. But here's what makes Musk's analysis so controversial. He's not invoking exotic physics. He's not suggesting alien technology. He's simply pointing out that the numbers don't add up, the energy budget is broken. Something is supplying power to this object, and we don't know what. The timing of these observations matters. Everything changed in the first week of November. Before that, 3I, ATLAS, behaved like a normal interstellar object. Predictable trajectory, steady brightness, minimal outgassing. Then something triggered. November 6th, the brightness surge begins. November 7th, the sideways deflection appears. November 8th, the gas output spikes. 3 days that changed everything. NASA hasn't released an official position yet. The European Space Agency remains silent. The International Astronomical Union says more data is needed. Everyone's waiting, watching, calculating. Because if Musk is right, this changes our understanding of interstellar objects. Think about the implications. Every model we have assumes interstellar objects are inert. Dead rocks or ice balls drifting through space, powered only by sunlight when they pass near a star, following predictable paths, behaving according to known physics. This object breaks those assumptions. The data forcing this conclusion comes from multiple independent sources. ATLAS in Chile, Lowell in Arizona, James Clerk Maxwell in Hawaii, the Minor Planet Center at Harvard. They're all seeing the same thing. Unprecedented activity, unexplained energy, impossible behavior. Musk's analysis pulls these observations together into one uncomfortable conclusion. The physics doesn't work, not with our current understanding. Here's where the debate gets even more interesting. Some scientists argue we're seeing a completely new type of object. Not a comet, not an asteroid, something else. A class of interstellar visitor we've never encountered before. With different composition, different structure, different physics. Others suggest we're witnessing a rare but natural phenomenon. Primordial ice with exotic properties. Amorphous water ice that releases energy when it crystallizes. Phase transitions we don't fully understand. Both explanations require revising our models. The November 18th Hubble observations will be critical. High-resolution imaging, detailed spectroscopy, direct measurement of the gas composition. If Hubble sees complex molecules, that suggests internal heating. If it sees only simple gases, that supports surface sublimation. But Hubble might not be enough. The real answers will come from the James Webb Space Telescope, November 21st through 24th. NIRSPEC will analyze the infrared emissions, measure the heat signature, determine the energy distribution. Those 4 days of observations will either confirm Musk's energy deficit or explain it away. The stakes couldn't be higher. If the energy deficit is real, we need new physics, or new assumptions about interstellar objects, or both. If the deficit disappears with better data, Musk's analysis becomes a cautionary tale about incomplete observations. Scientists are divided. The conservative camp insists on natural explanations. Measurement error, unusual but explainable ice chemistry, localized heating from radioactive decay. They point to decades of comet observations. Outbursts happen. Unexpected brightening occurs. Physics always wins. The progressive camp sees an opportunity. Maybe interstellar objects carry primordial material with exotic properties. Maybe the interstellar medium alters matter in ways we don't understand. Maybe our physics is incomplete. Musk positions himself between these camps. His analysis doesn't claim to have answers. It identifies a problem. A massive, glaring problem with the energy budget. He explicitly states that future observations will determine the truth. Either the data will reveal a conventional explanation, or it won't. And if it doesn't, then we're looking at the most significant discovery in astronomy since dark energy. The public reaction has been explosive. Social media is calling it everything from vindication for UFO believers to bad math from a billionaire. Scientists are being unusually public with their disagreements. Twitter threads dissecting Musk's calculations. YouTube videos explaining the physics. Reddit arguments about thermodynamics. Everyone has an opinion, but opinions don't matter. Data matters. Physics matters. Energy budgets matter. Let's revisit the core. Numbers that started this controversy. 2 million kilograms per second of mass loss. That's not controversial. Multiple telescopes confirm it. The spectroscopic signatures are clear. The Doppler shifts match. The number is solid. 40% brightness increase in 48 hours, also confirmed. ATLAS has the light curves. The photometry is bulletproof. Independent observers verified it. The number is real. 15-kilometer lateral shift in 3 days. Measured. Confirmed. Cross-checked against background stars. Multiple observations. Independent verification. The number stands. These 3 numbers create the crisis. You can't explain all 3 with conventional physics. Pick 2 and you can make it work. All 3? The math breaks. That's Musk's point. The object is doing something impossible. Not improbable, not unusual, impossible. According to our current understanding of physics and energy conservation, some scientists argue the size estimates must be wrong. If the object is actually 10 times larger than we think, the energy budget could work. But that creates new problems. How did we miscalculate the size so badly? Why don't the reflected light measurements match? Where's the gravitational perturbation such a massive object should cause? Others suggest multiple objects, maybe 3, ATLAS fragmented. Multiple pieces creating the illusion of impossible behavior. But the imaging doesn't show fragments. The light curve doesn't show multiple sources. The spectrum is consistent with a single object. Every explanation has holes. That's what makes this so fascinating. We're watching science happen in real time. Not the cleaned up textbook version, the messy, controversial, argument-filled process of discovery, where experts disagree, where data conflicts with theory, where nobody has all the answers. Musk's contribution is forcing the conversation. Without his analysis, the anomalies might have been dismissed. Measurement error, instrumental artifacts, unusual but not impossible. His energy budget calculation demands attention. It can't be ignored. It can't be hand-waved away. The scientific establishment is responding. Papers are being rushed through peer review. Telescope time is being emergency allocated. Theorists are revising models. Everyone wants to solve this puzzle, either by proving Musk wrong or by explaining what he found. The clock is ticking. 3I, ATLAS, won't stay visible forever. It's already starting to fade as it moves away from the Sunday. We have maybe 3 months of good observations left, maybe less. Every night matters. Every measurement counts. The Hubble observations start in 4 days. November 18th, The Space Telescope will turn its instruments toward this mysterious visitor. 2 days of intensive observation, capturing images and spectra across multiple wavelengths, looking for clues, searching for answers. Then comes Webb, November 21st through 24th. The most powerful space telescope ever built will examine 3I, ATLAS, in unprecedented detail. Infrared emissions, heat signatures, molecular composition. If there's an internal energy source, Webb will find it. Or Webb will find nothing unusual. Either outcome reshapes our understanding. If Webb confirms the energy deficit, we're facing a scientific revolution. Our models of interstellar objects need complete revision. Our understanding of energy and matter in deep space requires fundamental updates. Textbooks need rewriting. If Webb explains the deficit, we learn something crucial about extreme solar system phenomena. How ice behaves under exotic conditions, how primordial material responds to stellar radiation, how our instruments can deceive us. Win or lose, science advances. That's what Musk emphasized in his analysis. This isn't about being right. It's about understanding. The universe is telling us something through 3I, ATLAS. We just need to figure out what the competing interpretations remain unresolved. Natural explanation supporters point to historical precedent. Comet Holmes brightened by a factor of 1,000,000 in 2007. Comet 17P showed impossible energy output until we understood its ice composition. Unusual doesn't mean impossible. But 3I, ATLAS, isn't a periodic comet. It's an interstellar visitor. Different origin, different composition, different physics? That's the question Musk's raising. Do the rules change for objects from interstellar space? Have we been making incorrect assumptions? The answer will come from data, not debate. Every major observatory is now tracking 3I ATLAS, the Very Large Telescope in Chile, Keck in Hawaii, Subaru in Japan. Radio telescopes are listening for emissions. Infrared detectors are measuring heat. Spectrographs are dissecting light, all trying to solve Musk's energy puzzle. The latest development came yesterday, November 13th. The Gran Telescopio Canarias detected unusual emission lines in the object's spectrum, lines that don't match typical cometary emissions. The team is still analyzing, still calculating, but preliminary results suggest complex carbon chains. Complex carbon chains require energy to form. Where did that energy come from? The mystery deepens with each observation. Instead of converging on an answer, the data keeps raising new questions. Why the sudden activation in November? Why the specific pattern of brightening? Why the precise timing of the lateral shift? Patterns that suggest, what? Musk won't speculate beyond the energy deficit. His analysis is rigorous, mathematical, constrained. He identifies the problem, quantifies it, then stops. No wild theories, no exotic explanations, just physics and math. That's what makes it so powerful. You can't dismiss it as speculation. The numbers are right there, published, verified, reproducible. Anyone with a calculator can check his math. The energy doesn't balance, period. The question becomes, what are we missing? Is our understanding of physics incomplete? Are our observations systematic wrong? Is this object fundamentally different from anything we've studied before? All three possibilities are on the table. The scientific community is racing against time. 3I. ATLAS is heading back to interstellar space. Every day takes it further from the Sunday dimmer, harder to observe. Soon it will be beyond our instrument's reach. We might never see another object like this. That pressure is driving unprecedented cooperation. Data that would normally take months to release is being shared in days. Competitors are collaborating. Resources are being pooled. Everyone recognizes this moment's importance. Because Musk might be right. The energy budget might be broken. Physics might need updating. Our cosmic models might be incomplete. Or he might be wrong in the most interesting way possible. The solution to the energy deficit might reveal new chemistry, new ice physics, new mechanisms for energy storage and release in primordial material, discoveries that reshape our understanding, even if they don't break physics. That's the beauty of this moment. We don't know what we're about to learn, but we know we're about to learn something profound. Whether it confirms our physics or challenges it, whether it validates Musk's analysis or refutes it, the universe is teaching us, through 3I, ATLAS, we're glimpsing something new, something unexpected, something that doesn't fit our careful models and proven theories. The next 10 days will be critical. Hubble on the 18th, Webb on the 21st, ground-based observations filling the gaps, each measurement adding pixels to the picture, each spectrum adding colors to the portrait. By November 25th, when the Minor Planet Center releases its updated orbital solution, we'll know if the mystery deepens or resolves. If the energy deficit persists after Webb's observations, the implications cascade through astronomy. Every interstellar object becomes suspect. Every assumption needs verification. Every model requires scrutiny. If the deficit disappears with better data, we still win. We'll understand what created the illusion, what combination of factors fooled our instruments, how to avoid similar confusion in the future. The controversy Musk ignited serves science either way. It forced attention on anomalies that might have been ignored. It demanded rigor in our observations. It exposed gaps in our understanding. It reminded us that the universe still holds surprises. That's what great science does. It doesn't just answer questions. It asks better ones. It doesn't just solve puzzles. It reveals deeper mysteries. 3I, ATLAS, is doing exactly that. Through Musk's energy budget analysis, this interstellar visitor is challenging our fundamental assumptions, testing our physics, pushing our instruments to their limits, forcing us to confront what we don't know. The data will decide. Not opinion, not authority, not consensus, pure, unforgiving data. Measurements that don't care about our theories. Observations that don't respect our assumptions. Numbers that tell the truth whether we like it or not. That's what we're waiting for. The truth about 3I, ATLAS. The resolution of Musk's energy puzzle. The answer to whether physics needs revision or our observations need refinement. 4 days until Hubble. 7 days until Webb. 10 days until we might understand what we're really seeing. The object continues its journey, ejecting mass, defying energy budgets, challenging our understanding. Every second, another 2 million kilograms of matter explodes into space. Every second, the mystery deepens. What scientists discover in the coming days could change everything, or confirm everything. Either way, 3I, ATLAS has already earned its place in history as the object that made us question our assumptions, that exposed the limits of our knowledge, that reminded us the universe still has secrets. The energy deficit Musk identified is real. The explanation remains unknown. The answer is coming.